Welcome back to the Parent Effect. This is the 2023 paper. It is fresh. It is straight off the from Wednesday. So today is Saturday. The kids sit it on Wednesday, and I'm just going to go through all of the answers. So if you did sit it, or you are going to be sitting an exam later in the year, hopefully this will help you out. So it's version 13, so that we sit here in New Zealand for the May-June series. So the first question was a transformation question. So they just wanted you to describe the two transformations in full. So if we look at, first of all, what's going on. So it's gone from a B, C here to the A dash, B dash, C dash. So hopefully you can see that it has actually moved down. So all of the points have moved down 2. Okay, so B is now in line with that, C is now in line with that, and A is in line with that. So the first one that I would describe is a translation. That gives you 1 mark for saying translation. And then you have to describe what it is. I would usually use vector notation, so 0 across and -2 down, but you could also say 2 down if you wanted. The next thing that's happened is that it has been stretched. So if you can think of the y-axis as like the invariant point and you're pulling away from it, everything has moved away from it. So at the moment, A is 1 away from the y-axis and now it's 2 away. This one was 2 away, it's now become 4 away. Okay, so all of the points are 2 times greater away from the y-axis. So that is called a stretch. Scale factor 2 horizontally. And that will give you your 4 marks for that one. Right, having a look at the next one. This one was quite interesting, and it's not actually difficult, but I think the way that they worded it made it a little bit more tricky than what we've seen in the past. So we've got a function, and it is given that it is always greater than 2. So what that's really saying is that if we drew a picture of it, that its vertex must always be greater than 2. So the whole graph is from the lowest point is 2 and it goes up from 2. So when we're thinking of the vertex, this point here, we're wanting that y value to be 2. How do we find the vertex for any graph? Well, we need to complete the square. So that's the first thing that I would do with this. So when we complete the square, we halve that number, we subtract that number squared, and then we drop the constant down. And then if we were reading the vertex off this, the vertex would be at 3 and -9 plus c. So this is the critical bit that we need to be greater than 2. So we simply set that greater than 2. So c is greater than 11. So actually wasn't too difficult, but I think interpreting it could have been quite challenging. Right, the next question. I found this quite interesting because I always tell my students, oh, they never ask for the complete expansion. They always ask for just the first 2 or 3, maybe 4. But no, now they ask for the complete expansion, and it was only worth 2 marks. So quite interesting to see that coming in. That's just using the binomial theorem formula. So if we just quickly have a look at that, if you really need to familiarize yourself with the lovely MF19. So it's on the first page here, and you'll see it's the binomial series here. So we're just substituting in for A and B. I have some other tutorials on how to do this, but essentially you'd be just taking what A is, which is x to the power of 5. The next one, the C's start coming in, so it'd be 5c1, x to the power of 4, and B starts coming in. Now notice these here, they always add to 5. There's lots of patterns here, so always keep double checking that the pattern is working. This is 5c1, 5c2, etc. I'm going to have x to the power of 3 this time, so it's gone 5, 4, 3. 5c3. 5c4, I'm going to run out of room. The last one, I mean, you can put 5c5, it's just 1. X to the power of 0, again, you could put that, it's just 1. It's really just 2x to the power of 5, so you don't even really need that bit there. So just simplifying that, you're going to end up with x to the power of 5 for that first term. The next one becomes 10x to the power of 3, because you've got x to the power of 4 on the top here and 1x on the bottom here. Okay, so they cancel out. Next one becomes 40x. You've got x cubed on the top here, and you've got x squared on the bottom. Just be mindful of that. That is 2 to the power squared. So on your calculator, to get the 40, you're going to do 5c2 times 2 squared. Okay, and for this one, you're going to go 5c3 times 2 cubed. So just be mindful that those 2's are to the power of something as well as the x. And this was the final answer. So for this one, you're just doing 2 to the power of 5 is 32, and x to the power of 5 is on the bottom. So there then was an extension of that question, just wanting to know if we then multiply that answer by a plus bx squared, we're wanting to look at the coefficient of x and the coefficient of 1 over x. So this type of question is more similar. So all I did is chucked all of that in, and then I started looking for what would give a coefficient of x and what would give a coefficient of 1 over x. So first of all, if we're thinking about the coefficient of x is 0, what on earth is going to multiply to give us x? So hopefully you can go see that if I multiply a by 40x, that's going to give me a term that's just got x in it. So we've got 40ax there. The other way I could get x is if I take this one and times it by this one, because x squared on the top and x on the bottom is going to cancel out. So bx squared times 80 over x. The x squared is going to cancel out with one of those, and I'm going to end up with 80b x. So when it says the coefficient of x is 0, it means that 40a, which is a coefficient here, and the coefficient here have to give 0. So therefore we know that that's going to be one of our simultaneous equations that we're going to end up needing to do. So the next one, I'm going to use a different highlighter, is the coefficient of 1 over x. So things that would give 1 over x. So if we do a times 80 over x, so a times 80 over x is going to give us 80a over x. And then also if we do bx squared, and we're wanting x cubed on the bottom, so it's going to be this one. So if we go bx squared times 80 over x cubed, that's going to give us x on the bottom and 80b. Too many 80s for my liking, because that of course has to equal 80 as well. So by that point I was like, no, I'm over the 80s. Simultaneous equations between these, so you can just do elimination method. So 40 minus 80 is negative 40a. And then 80 minus 80 is nothing, and 0 minus 80 is negative 80. So A was, of course, 2, and it ended up that B was 1. Didn't actually give that much room for that question, considering it was 4 marks. Right, question number 4. So this one, they asking you to express it in terms of cos. So it's not a proof because it equals 0. It's just an equation. So we can use both sides. So the first thing I would do is change it to sine squared x over cos squared x. And once I've done that, I would multiply everything by cos squared just to get rid of that fraction because we don't really like fractions. So that gives us 3 sine squared x cos squared x. And then negative 4 cos squared x. And then, of course, when you times by 0, it's gone. Now, the beauty of sine squared is we can use the fact that cos squared plus sine squared equals 1. So wherever I have sine squared, I can replace sine squared with 1 minus cos squared. So that's what I'll do in the next step. And that is making sense because we're going to end up with cos 4. So you can see that there's going to be cos 4 in that section there. Maybe when you're doing this in the exam, just to take it really slowly because it's so easy to make a mistake. So multiplying that 3 out. And then this one is going to be minus 3 times cos squared. Minus 3 times minus cos squared times minus cos squared. So it's going to be positive 3 cos to the 4. And then the 4 cos squared. Nothing happens to that. And then we're just tidying it up. There's only 3 cos the power 4 here. We've got negative 3, minus 4, which gives us minus 10, and just the positive 3 there. And we are done. They then ask us to solve it just between 0 and 180. So we can factorize this one, and we end up with cos squared x is equal to 3, or cos squared x is equal to 1/3. Of course, this has no solution. This one, when we square root it, cos x can equal plus or minus root 1/3. So we need to inverse cos each of those, and that ended up with 54.7. Remember, degrees need to be in to 1 dp, not 3 sig figs like the rest of them. Okay, so that was a disguised quadratic. I'll just quickly put here. So basically you're thinking of it like this, and then factorizing from there. Right, next question was a circle. So we have a circle and it's intersecting with a line. So what we're going to do there is simultaneous equations. So we're going to replace y in this one with x minus 9. So if I have x minus 9, I'm then going to be adding 4, and then I can just tidy that up. So expanding that first lovely bracket, I have x squared minus 2x plus 1, and this one has become x minus 5 squared. So expanding that second one is x squared minus 10x plus 25, and then just collecting everything together to make a new quadratic. So we have plus 26 on the side, minus 40, so we get minus 14. So at that point, I will just divide everything by 2. So we get x minus 7 and x plus 1. So therefore, x is equal to 7, or x is equal to negative 1. Putting that back into this original one, 7 minus 9 is negative 2. And negative 1 minus 9 is negative 10. So those were our coordinates of A and B. We then have to find the equation of the circle with diameter AB. So there's 2 things we need to know for an equation of a circle. We need to know the midpoint, and then we need to know the radius. So we're going to be finding, first of all, the midpoint. So to find the midpoint, you just average the x's and average the y's. So the midpoint, 7 minus 1 is 6. Divide that by 2, we get 3. -2 plus -10 is -12. Dividing that by 2 is 3, -6. The next thing we need to know is the distance of the diameter to help us find the radius. So just remembering the distance formula, that's not on your formula sheet. So you take the x's, find the distance between, subtract them, square them, basically using Pythagoras. So chucking these into our formula, we're going to go -1 minus 7 and -10 minus -2. So we end up with a square root of 64 plus 64. So it's a square root of 128. Now remember, that's actually the diameter, and we don't actually want the diameter, we want the radius. So the radius is going to be 128 square root divided by 2. When we give the equation of the circle, you're going to go the midpoint. Remember, when it's in brackets, it changes sign. Plus 6. And then the radius has to be squared. So it actually ended up being 32. Again, thought they were a bit mean on the amount of room. Right, the next one. They told us the length of the arc here. So this arc is 9.6, and they also told us the area of the whole sector. So the sector is like the pizza slice, is 76.8. So first of all, just writing those down. So the formula for the arc length, which is on your formula sheet, is r theta. So that's 9.6. And then the formula for the sector is that, and that was 76.8. So basically, again, it's simultaneous equations. We've got two equations. We've got two unknowns. So I just made this slightly prettier. And then I made theta the subject for this one. No, you could have made r the subject and chucked that into here. So r squared times 9.6 over r equals 153.6. Those cancel out, so that r was beautifully 16. And that meant that theta, just putting it back into the equation, is 9.6 over 16, which equaled 0.6. So if we want to find the area of the shaded area, you want to do the area of the sector minus the area of the triangle. We already knew the sector, it was 76.8. And for these, I would use half AB sine C for the area of a triangle. So just remembering that A and B have to be either side of the angle in the middle. So using that formula, A and B were both R, and sine theta would have been 0.6. Chucking that on the calculator, making sure that you are in radians, and you get 4.526, which you could, of course, should do 3 sig figs, so 4.53 centimeters squared. We then had to find the perimeter of the shaded region. So to do that, we're needing to find this length of this. So what I looked at was actually the right angle. So if I just draw a picture of the right angle down here. So we wanted to know what that was. We knew that this was R, which is 16, and this, we just halved it, so it's 0.3. So just using traditional trig, sine, I don't know why I've gone to yellow, sine of the angle is equal to opposite over hypotenuse. So it ended up being x is equal to 4.73. But of course, because we're actually looking at this whole bit, we need to add 2 lots of x plus 9.6, which gives us 19.06 centimeters, or 19. Right, question 7. So a nice function question here. So this is looking at the range using the fact that they've restricted the domain. It's easiest if you have a rough idea of what these equations look like. So obviously it's, well, maybe not obviously, this is a hyperbola. So it's going to be, we're looking at where it's going to have asymptotes. Okay, so the x plus 2 is meaning it's going to have an asymptote at where x is -2 because we can't divide by 0. And then the whole graph's been shifted up too. So it's looking like that. Now, it's going to be running along like this. So when it says that x can only be greater than -2, we're clearly just looking at this side. So hopefully you can see from this that this asymptote here is 2, so y can only be less than 2. So that is the range. You could put f of x. It's probably better. Right, obtain an expression for the inverse and state the domain of the inverse. So state the domain is, as soon as you see the word state, it's essentially going to be obvious, and that's because it's pretty much the answer from above. The domain of the inverse is the range of the original. So remember, the definition of an inverse is just that x and y have switched around. So if y was less than 2, x has become less than 2. So that's 1 mark there. Doing the inverse, you just need to switch them around. So it's going to be x is equal to 2 minus 5, y plus 2. And then the whole process is just trying to make y the subject. So the first thing I would do is move the 2 over. And then multiply the y plus 2 up, expanding this out. Oh, that's a minus. And then your aim is just to put all the y's on one side and anything else on the other side. So on this side, we just have xy minus 2y. On this side, we have -5 plus 4, so -1. And then we're retracting the 2x over, making factorizing y out. And y would equal, you can, of course, times the top and bottom by -1 to get rid of all those negatives, which is what Cambridge likes to do. Heaven forbid we should have any negatives. So if you got that, that is also correct. Right, moving on. Well, not really. We're using the same question. So essentially what we're doing is we're going to be replacing what x is with g of x. So g of x is x plus 3. So just reminding you what the equation actually was, we had 2 minus 5x plus 2. So all we're doing is, instead of having x written there, we're going to write all of gx, so x plus 3. So it's going to be that. But of course, they don't want us to leave it like that because that would be too simple. So they want us to rearrange it to look like this. So essentially, we're wanting to make them have the same denominator. So they're both going to be over x plus 5. In order to make this have that denominator, it needs to be times by x plus 5. And then that's going to be 2x plus 10. So that leaves us with 2x plus 5 over x plus 5. So that gives you what A, B, C, and D are. Right, moving on to question number 8. So we've got a progression where the first term is a and the second term is a squared over a plus 2. And they're saying for the case where the progression is geometric and the sum to infinity is 264, find the value of a. So if it's geometric, we can find out what or we can find an expression for R. So R is always, if you have any consecutive terms, the further one divided by the previous one. So we can take the second term and divide it by A. Now, if you don't like having a fraction divided by something, that is cool because most people aren't. So remember, we can just times by 1 over it to help us with that. And then hopefully from there you can see that 1 cancels out with that 1. So we've just got A on the top over A plus 2. So that is a slightly simpler version of R, still pretty hideous. We can then use the next piece of information, which is that the sum to infinity is equal to 264. Now, the formula for the sum to infinity on your formula sheet is that. So we know that that is equal to 264. So we're going to replace R with that expression that we came up with. Now, again, it's not pretty. So the first thing I would do is multiply that over. So I've got A multiplied by 1 minus A over A plus 2. And then expanding that out. And in order to get rid of the fraction, I'm going to times everything by A plus 2. So on this side, I'm going to get A squared plus 2A. 264 is going to become 264A plus 528. And then this one's just going to be left with the 264 because that will cancel out with that. Making that a little bit simpler, we are going to end up with a fraction. Sorry, I lost an A. So I lost an A here. Yeah. So that cancels out with that. So chuck that into a calculator and you discover that A could be 22 or it could be negative 24. It did say that A was a positive constant, so it must be this one. And that was all it asked for was the A. So just put not positive, reject. Not sure if you'd lose a mark for that, but I always like to reject them just in case every now and then they are mean. Right, this time, instead of it being geometric, it is arithmetic. I'm just going to write the formula. So the first one was A and the second one was A squared over A plus 2 in the previous question. So we now know that A is 6. So the first thing we need to do is substitute A equals 6 into these two terms. So A is obviously 6 is the first term. The second term is going to be 6 squared over 8. So the second term actually works out to be 4.5. So we're going 6, 4.5. So we know A is 6 and D is negative 1.5. Now we know the sum needs to be less than negative 480. So we're going to use the sum formula for arithmetic series. And we end up with this. So we need to simplify this. So we're going to times the half over to get negative 960. And then timesing the 1.5 in. That's going to be negative 1.5. I've put, it's not, that's a plus. I tell you what, the number of times I make the silly mistakes with these is too many. I would take it very slowly if I was doing it in an exam. And then expanding that out, we get 13.5n minus 1.5n squared, and moving them all over to, I put them onto the left-hand side to make it positive. Chucking that onto a calculator, and was only one positive answer, which was 30.2. So we're going to say that the first time that that could possibly be is 31. Right. We now have a curve which passes through a point, and we're given the derivative. So we need to find the equation of the curve. So in order to do that, we need to integrate. And I would change that second expression to have -3 up there, because otherwise it's going to be very difficult to integrate. So we integrate, we add 1 to the power, divide by the new power. So this is the reverse chain rule. So we need to add 1 to the power and divide by that new power. So 2 divided by -2 is going to become +2. And then, of course, 2 divided by it's going to be +1, actually. And then we're going to add c on the end. Now we know that the curve passes through those points, so we can chuck in 3 for y and 0 for x. So c ends up being 2. So our equation is, if you want to make it on the bottom again, you can. That. Right, the next one is saying that we have a tangent to the curve at 0, 3, intersecting the curve again at one other point P. So the x-coordinate P satisfies that lovely equation there. So first of all, we need to find the gradient for that tangent. So to find the gradient of the tangent, m of tangent, we can replace x in our original equation here with 0. So it's going to be 1 minus 2 over 0 minus 1 cubed, and that worked out to be 3. So now we can find the equation of that tangent, because we now know that it passes through 0, 3 and has a gradient of 3. So using y minus y1 equals mx minus x1, y minus 3 equals 3x minus 0. So y is equal to 3x plus 3. So we know that this line intersects the original equation at another point. So we're going to take that equation of the curve that we came up with before, which was x plus x minus 1 squared plus 2, and it's got to equal 3x plus 3. And we know that it's going to happen at that point that they've already told us, 0, 3, but also at another point. Now, we don't actually have to solve it. We just have to show that this is the same as the equation they gave us up there. So I would move everything that's not over x minus 1 squared over to the other side, just to make things a little bit prettier. So we've got 3x, we're minusing x. 3 minus 2 is plus 1. And then 2x plus 1 timesing by the x minus 1 squared. And then lastly, they made it equal 0. So 2x plus 1, x minus 1 squared, and then we just subtract the 1 over, and we get what they got. Lastly, we just need to verify that 3 over 2 satisfies it. So just chucking that into the equation to check that it equals 0. So putting that in. And we do end up with 0. So then we find out what the y coordinate of P is by, I put it into the equation of the line because that seemed a lot easier. So y equals 3 times 1.5 plus 3, and we get 7.5. Right, we are on to the last question. So they want us to find the maximum point of the curve. So maximum points are found by differentiating setting equal to 0 and solving. So if we differentiate it, we are going to get 9 there, multiply by the power, take 1 off the power, and then divide by the derivative of the inside. So that's going to become 4 there. Sorry, I started to integrate. Times by the derivative of the inside. So times by 2, multiply by the power, take 1 off the power, and times by the derivative of the inside. Not that I have lots of internal mantras all the time. Okay, so then we're setting that equal to 0. So obviously 3 over 2 times 2 just becomes 3. And then I can move the 9 over. Divide by the 3 and I get 3 over here. Opposite of the square root is to square. So squaring that, I get that. Minusing 1 and dividing by 2. And I've got the answer. Do need to find the coordinate, so we then need to put it in. So putting that on the calculator. 2 times 4 plus 1 to the power of 1.5 is 9. Right, verify that the line AB is the normal to the curve at A. So to do that, we need to find the gradient of AB and compare it to the gradient of the curve. So the gradient of AB, I'm just going to put the points. So it's 1.5 and 5.5. No, I've got it wrong, haven't I? No, it was 1.5 and 5.5 and 7.5 and 3.5. So we're going to do rise over run, so y is over run. So 3.5 minus 5.5 over 7.5 minus 1.5. And if you do that, you get negative 2 over 6, which simplifies, of course, to negative 1/3. So then we want to show that the gradient of at A is going to be the opposite of that, the perpendicular of that. So we're expecting, if it's perpendicular, to be 3, and then we know if we've got it right or not. So gradient, because it's at A, is going to be when we put x equals 1.5 into our derivative. So our derivative was this one here. And so we put it in and we end up with 9 minus 3 times 2, which happens to be 3. And then I would just probably show that there's the formula m times m should equal negative 1 if they are perpendicular. And lastly, but definitely not least, we need to find the area. So to find the area, you're going to want to integrate. You're going to integrate the top function. And then you need to subtract integrating the bottom function. So we need to find the equation of that line, equation AB. And we need to do it between these 2 points. So we're essentially doing it between here and here. So 7.5 and 1.5. So I would, first of all, tell the examiner that, because they love to give us method marks. Even if I'm just writing down my strategy, really. So, and I always tell them over here, I'm doing the equation of AB. So they know what on earth I'm doing. So the equation of AB, we've got all the info. We've got the point, or you can choose either point, and we've got the gradient. We did that before. And so we're just going to simplify that, and you end up with negative 1/3 x plus 6. And then that's going to go in here. So we're integrating all of this beautiful stuff. We're subtracting it, so minus than 1/3, it's going to become positive, and minus 6. You can work them out separately if you prefer. Okay, so now we want to integrate it. So adding 1 to the power, dividing by the new power, 4.5. Add 1 to the power, divide by the new power, and divide by the derivative of the inside. Add 1 to the power, divide by that new power, and that becomes 6x. And then it's just the tedious putting 7.5 or 1.5 into the calculator. And you get 12.7 minus negative 4.9, which gives us 17.6 or 88/.